Download this code from codegive.com, link in the description below. Functional error handling in CodeSignal, a deep dive with examples. Functional programming promotes immutability, pure functions, no side effects, and composition. When it comes to error handling, these principles lead to a different approach compared to traditional exception-based error handling. Instead of throwing and catching exceptions, functional error handling emphasizes representing potential errors as data and handling them explicitly within the code flow. This leads to more predictable and manageable code. This tutorial will explore functional error handling concepts in CodeSignal, focusing on techniques applicable in languages commonly used there, like JavaScript, Python, and Java, though we'll prioritize JavaScript and Python for examples as they are more prevalent in CodeSignal solutions. Key concepts of functional error handling *. 1. Representing errors as data *. Instead of exceptions, we use specific data types to represent successful results and potential errors. Common choices include: option /maybe * indicates the presence or absence of a value. It either holds a value, some, or indicates no value, none / nothing. Result /either * represents either a successful result, OK / right, or an error, error/left. This is the most flexible and commonly used approach. Tagged unions / discriminated unions * language-specific constructs that allow representing different data types within a single type, often used to differentiate between success and error states. 2. Handling errors explicitly *. We avoid relying on implicit exception propagation. Instead, we explicitly check for error conditions and handle them using functions like map * applies a function to the value inside a result / option if it's a success, otherwise, it propagates the error. Flat map / bind * similar to map, but the function being applied returns another result / option, allowing you to chain operations that might fail. Or else /default to * provides a default value to use if the result / option represents an error / absence. Fold / match * processes the result / option based on whether it represents success or an error, allowing for different code paths. 3. Immutability and pure functions *. Error handling functions should be pure, they should not have side effects. This means they only operate on their inputs and return a new result / option, leaving the original data unchanged. This makes reasoning about code much easier. Code examples: JavaScript. JavaScript doesn't have built-in result or option types. We need to either use a library, like FPTS or never throw, or implement basic versions ourselves. For demonstration purposes, we'll implement simple result and option types. 1. Implementing result and option types ***. Explanation of the JavaScript example ***. We define basic result and option types with OK / some for success and error / none for failure / absence. Divide function returns a result to indicate a possible division by 0 error. Save parseInt returns a result indicating if the string was successfully parsed to integer. Flat map is used to chain result operations. If any step returns an error, the whole chain short circuits. It allows you to pipe together functions that also return a result. This is crucial for functional composition. Fold is used to explicitly handle the result, either process the successful value or handle the error. Or else provides a default value if the result is an error. The main advantage is explicit error handling instead of implicit exceptions. We are forced to consider error cases. Code examples: Python. Python doesn't have built-in result or option types either, but we can create similar functionality using classes or data classes, if using Python 3.7+. We'll use data classes for a concise implementation. The returns library is an excellent choice for production code, but for demonstration, we'll create a basic one. Explanation of the Python example **. We define OK and AIR classes using data classes. Result is a type hint for the union of OK and AIR. We implement map, flat_map, fold, and _else methods. Divide and safe_parse_int functions return result instances. Flat_map is crucial for chaining. It allows one error to abort the entire process. Fold provides explicit error handling. _else gives a fallback value. The match case example provides a modern way to handle the result. Code examples: Java. Java doesn't have native support for algebraic data types like result or option. Libraries like Vavra and JOOQ provide these types. Here's an example using a basic hand-rolled result class for demonstration. Explanation of the Java example *. We define a result class with a value, error, and is OK flag. You could use generics to make it type safe. Static methods OK and AIR create result instances. Map, flat map, fold, and _else are implemented to handle success and error cases. Safe parseInt and divide functions return result instances. The main method demonstrates how to chain operations using flat map and handle the result using fold and _else. Applying functional error handling in CodeSignal *. When tackling CodeSignal challenges, consider these scenarios where functional error handling can be beneficial. Input validation * use result or option to represent the success or failure of validating user input. Data transformation * when transforming data from one format to another, use result to indicate if the transformation was successful. Handling external API calls * when making calls to external APIs that might fail, use result to represent the success or failure of the API call. Arithmetic operations * for operations that can cause errors, like division by 0, return a result. Example CodeSignal problem and solution, JavaScript. Let's say you have a CodeSignal problem where you need to 1. Parse a list of strings into integers. 2. Calculate the average of those integers. 3. Return the average as a string, formatted to 2 decimal places. 4. Handle the case where any string cannot be parsed to an integer, or the list is empty. Explanation of the CodeSignal example *. 1. Parsing * safe parseInt, in the earlier examples, would be used here, modified slightly. Each string is converted to a result number, string. 2. Averaging * a reducer is used to accumulate the numbers. The reducer also checks for any error encountered. If an error exists, the reducer simply returns that. 3. Empty list handling * checks for an empty input and returns an appropriate error. 4. Formatting * uses fold to format the successful average to 2 decimal places or return the error message. Benefits of functional error handling *. Explicit error handling * forces you to consider and handle error cases directly. Improved readability * the code flow is more apparent as errors are handled in the main logic, not hidden in exception handling blocks. Testability * pure functions and immutable data structures make it easier to test your error handling logic. Composability * result and option types allow you to chain operations that might fail, creating complex workflows while maintaining error handling. Predictability * no surprise exceptions interrupting program flow, leading to more reliable code. Drawbacks * Boilerplate * can require more explicit error handling code than exceptions. You need to define and work with the result or option types. Learning curve asterisk requires understanding functional programming principles and the specific error handling constructs you are using. Performance asterisk the creation of result and option objects can have a slight performance impact compared to exceptions, although this is often negligible. Conclusion asterisk. Functional error handling is a powerful technique that improves code quality, readability, and maintainability by representing errors as data and handling them explicitly. While it might require more upfront effort and a shift in thinking compared to traditional exception-based error handling, the benefits in terms of code clarity and reliability often outweigh the costs, especially in complex applications or when working in teams. By understanding the core concepts and practicing with examples, you can leverage functional error handling to write more robust and predictable solutions on CodeSignal and beyond. Remember to choose the approach, result, option, or tagged unions that best fits the specific problem and your chosen programming language. Remember to use libraries where possible to avoid reinventing the wheel. Good luck coding.